Hello dear students, welcome to the session of Zoom Academy. In this session, we will learn about solving a linear programming manufacturing problem. So here's the question on your screen. A sporting goods manufacturer two types of skis, a racing model and a freestyle model. Each pair of racing skis requires 3 hours of labor and the company can produce at most 20 pairs of racing skis per day. Each pair of freestyle skis requires 2 hours of labor and the company can produce at most 30 pairs of freestyle skis per day. The maximum number of hours of labor available for ski production is 96. The profit on each pair of racing skis is $30 and the profit on each pair of freestyle skis is $40. Find the number of each that should be manufactured in order to maximize profits. That's part A of the question. Now let's come to part B. Suppose the profit on each pair of freestyle skis is $20. Show that there is more than one way to maximize profit. As you all know that this is a linear programming problem. First we need to formulate the equation, then we need to plot the graph. First of all, let the number of racing model pair be X. Similarly, freestyle model be Y. According to the given data, we will first frame an equation for time. So, it is given in the question that racing skis require 3 hours of labor and freestyle requires 2 hours of labor. So we come to the equation 3x plus 2y is less than equal to 96. Here we use less than equal to sign because it is given in the question that the maximum number of hours of labor available for ski production is 96. Next we will find our objective function. The objective function here is nothing but it is denoted by Z and it is basically the equation for maximum profit. So our objective function here is 30x plus 40y. This is so because it is given that the manufacturing industry can produce at most 30 pairs of freestyle skis and 20 pairs of racing skis per day. Now we will formulate another equation because it is given that the manufacturing company can produce at most 20 pairs of racing skis. Hence, x is less than equal to 20. Similarly, y is less than equal to 30 because it is 30 pairs of the freestyle skis. So now let's come to solving this question. First, we will plot the graphs for equation number 1, 2 and 3. And this is our final equation, equation number 4. Now let's make a table for equation number 1. For equation number 2 and 3, no table as such is required because only a single variable is involved. So we come to know that if we put x is equals to 0 here, then y will be 48, and if y is equals to 0, then x will be 32. We are done with all the equations here. Now let's come to plotting the graph. Here I am taking a graph with scale on x-axis 1 centimeter is equals to 10 units, and on y-axis 1 centimeter is equals to 10 units as well. First we will plot our points 0, 48, which lies somewhere here. Then 32, 0. Now let's join this line. Okay, so now we will plot graphs for x is less than equal to 20 and y is less than equal to 30. This line is for x is less than equal to 20. And this line here is for y is less than equal to 30. Okay, so we are done with plotting the graphs. Let's label them now. Now let's take a reference point to get the area of feasible region. The point to be noted here is that the reference point should not lie on the lines. Suppose we take a reference point as 50, 0. If we put 50, 0 in equation number 1, we get 150 is less than equal to 96, which is false. So the bounded region here will be shaded. If we put 50, 0 in equation number 2, then we get 50 is less than equal to 20, which is again false. So again here the bounded region will be shaded. Now let's take 50, 0 in equation number 3, that is y is less than equal to 30. So we get 0 is less than equal to 30, which is correct. So again the bounded region here will be shaded. Using the three graphs, we find the common area of intersection, which is this portion. I am shading it. If we look at this figure has 5 corner points. Next, we will label these all corner points. The first point here is 0, 30. Point number 2 here is 12, 30. I am writing it again, 12, 30. Point number 3 here is 18, 20. Point number 4 is 20, 0. And point number 5 is 0, 0. That's the origin. Next, we will put all these 5 points in our objective function, that is equation number 4, one by one. Let's first write these points in our table. When we put these points in our objective function, we get 30 into 0 plus 40 into 30. That is equal to $1,200. So the final amount is $1,200. Next we put point number 2 in our objective function. So we get 30 into 12 plus 40 into 30. So altogether we get $1560, that is 1560. Now we put point number 3, 30 into 18 plus 40 into 20. So here we get 1340 as the amount, $1340. Now if we put 20, 0, then we get $600. And if we put 0, 0, then our net amount is $0. Now if we look at the amount carefully, the amount 1560 is the maximum among all these amounts. This implies that x is equals to 12 and y is equals to 30 is the optimal solution. Hence 12 pairs of racing models and 13 pairs of freestyle models is the required number. Thanks for watching. Stay tuned for more videos.